Welcome back, Internet. Today, the world brings to us the 97 Jeep Cherokee. It's got the 4 liter and like 244,000 miles on her. The story goes they were driving along and come to a red light, and when they hit the red light, the engine stalled. Once the engine stalled, they pushed that vehicle out of the road, and then after being parked on the side of the road, the shifter would no longer come out of park. The engine would still crank, but would not fire. On occasion, it's history. On occasion, over the past couple of years, carb cleaner was sprayed into the engine to get it to fire, and once running, there were no further issues. So apparently, that's been going on for a couple of years. It seems like occasionally it might lose a little bit of fuel pressure or something like that. But said they always got it going with a little bit of, some sort of flammable liquid in the intake. And the only other thing we got on her is an aftermarket radio is installed 5 years ago. So currently it is a crank, no start. Pretty unique that we have this inability to come out of park at the exact same time we have an engine stall and uh, the occasional crank no start of a couple, been going through a couple of years. So this one will be interesting. Other than doing a pre-check, I haven't done anything else to it. I'm just trying to brainstorm and think what could be in common between no engine running and no out of park signal. Those are interesting. The only thing I could come up with in my mind before we've done any work to or haven't scanned it, haven't looked at wiring diagram codes, nothing. I'm curious about a power distribution issue. If we've got power going to the Prindle gate, lacking, perhaps it won't come out of park. And then certainly if we got power lacking going to some other engine system, might make sense it wouldn't start. But I just want to know right now, it cranks, it don't start. Let's go ahead and get a scanner plugged into her and see what kind of code she's got. Right off the bat, now I can never remember when check engine lights coming on with keys started being a thing, but this is a 97. I kind of think it should be a thing. If I key off and then key on, we do not have any check engine lights, and it took me a second to find it, but it is right here. I don't know if this camera will actually pick it up or not, but right next to the airbag light. So check gauges, blank, airbag. It goes right in between those two lights. That's where we should have a check engine light. We have no check engine light there. Let's let our scanner finish getting connected here. I guess I may as well record this. It says get the special connector. I've gotten this before and it didn't require it. I've got the connector back yonder, but let's see if we can get ABS and occupant restraint to actually read without it. Let's hit the fault scan. Oh, no topology. What world do we live in? We'll let this finish going through. Well, let me tell you, this thing thought long and hard about trying to communicate with those, and we have no comm with anything. So we'll go ahead and put our CCD, I think it's Chrysler Collision Detection connector in. That just goes right in here to the actual OBD connector. As simple as plugging in an OBD connector. Regardless, there's our additional plug. We'll go through and we will hit the fault scan again. Oh, wait. I may have just screwed this up. Actually, it's a good thing I recorded this. Last time I did this, I had to exit the vehicle and re-enter the vehicle information in order for the CCD connector to work. I don't know if that's going to be the case, but we may have to exit back out. It was just sitting there spinning. I want to exit it out of the vehicle, re-put in the VIN. Yep, please connect. Okay, so we did that. Got our module list. We'll hit fault scan. Now we'll see if it, who knows, it may just take as long again, but we'll see if it actually pulls anything this time. All right, with the CCD connector in, we do have, the only module responded was the airbag. Let's go in here and see if we can actually look at live data or something. Trouble codes apparently is the only thing we can read here. I don't know if this is going to take forever, but kind of looks and seems like we're going to go after a power distribution issue to the engine computer. It says no codes detected, so I'm assuming it can communicate with that. Let us go. Oh, I guess we could do a crank I can just show you it's cranking. Let's see if we watch the tach and see if it moves. I don't know if the mics will pick it up, but we'll go ahead and crank. So that was it cranking. Sounds pretty equal cadence, but we had no tach movement. Definitely think we're going over or going after some sort of power distribution issue. Let's pull out wiring diagrams and figure out what the computer and potentially the brake switch and or the Prindle or shift interlock all have in common. And then, I don't know, probably just check fuses, I guess would be the logical place to start. Let's go find that info. Oh, I was just thinking about what I said right as I got out of the vehicle. The brake switch does work because the brake lights work. When I did a exterior lighting check on it, I jammed the pedal of pressure in the brake switch or the brake pedal. Tail lights do, or the brake lights rather do work. I can't speak right now. So we know we've got a good brake switch, but whatever it goes to or controls, we'll figure out what controls the shift interlock and go from there. Probably PCM. All right, well, I could not readily find a bunch of shift interlock stuff, but we got some PCM stuff. All the diagrams are kind of scattered on this one. It's a little annoying, but we got a couple of fuses and a couple different fuse boxes. So there's one there, and I believe there's one inside. And we also got some data link connector power stuff. Specifically, I was curious on this one. Let's see if we can see it. Airbag control module. Looks like it connects to pin 11 of the data link connector, whereas the engine computer and trans computer and ABS module, all these three, connect to pin 7. It looks like two different pins there. Guess it's possible we could have a network issue also. That said, I'm just going to go through and check all the fuses to start. I think it's a logical place to start. And then, depending on what we find, we will start tracking a blown fuse issue, or we will move to a, I'll get my test light to connect here somewhere somehow. We'll move to potentially a network issue on whatever old CCD network this thing is. Let's see, power. Lots of powers. These are all the big fuses. All right, all our big fuses are a bit good. Let's check our small ones. And some of these are a little hard to get into. A couple of these have been replaced. They don't all match. Oh, wait. The key's off. I don't know if that makes a difference or not. Let me go turn the key on. Please hold. All right, now that the key is back on, let's recheck all these small ones again. And see what's up. Alright, well, the ones that have power anywhere have power on both sides. There's one that doesn't have any power at all. It's the second one in. How do we read this? Second one in, 15 amp. It doesn't tell me what it's actually for. That's okay. Well, let's go ahead and move to the inside fuse box and see if anything's blown there. We're on passenger side. There's our internal fuse box. I surely can't get the camera and my face in there at the same time, so I'll just go through those and let you know if I'm. Well, all the ones that have power to one side have power to the other. There's a handful that don't have power at all. I guess at this point we will pivot to the engine computer. And we'll just pull the connector views and check powers and grounds and communication at the PCM and see if one of those is missing. Back into the engine bay, I assume that is our engine computer. We've got 3 connectors, got a few powers, ground, and then so I've got power, ground, and comm, and 5-volt supply listed. We have a black connector, we have a white connector, and we have right-hand drive manual transmission, which I do not think is ours, but connector 3, all other models. We got a few things to test. I do not know what the SCI transmit and receive means. I'm familiar with the CCD bus, but I'm not familiar with SCI. I guess I got some looking to do a little bit later on. But anyway, I'm going to pull those connectors off, check these, figure out if any of them are missing. Probably don't need to record that whole thing. I guess if you want me to, leave it in the comments, but I'll bring it back to find something. All right, let me show you what we found so far. Connector 1, we tested good power, and then sensor return. Now, I'll say, I first started checking these with this unplugged. I figure power and grounds are going to be easier to check with it unplugged. When I had unplugged the sensor, our connector, our sensor return, this is the one where like all the engine sensors come back to it. All of those, this one was open. However, if we continue to look on, there's also a ground path in this connector as well. So with this connector unplugged, it's very plausible that this gets its ground through this. I checked this, re-plugged back in, and when it's plugged back in, this one returns. So we can cross off our X here and change that to a check mark. It does work. We had good ground there. This, we do not have 5 volts on. We got a difference in voltage there. Our fused B plus from the, we do have power, and then we have 2 good grounds as well. Likewise down here, we're missing our 5 volts. It's like 1 something volts. And then on the last connector, I didn't check any of these because they're not really relevant in the moment because I'm prioritizing our 5 volt issue. Looks like we got a 5 volt issue on this over some communication stuff. Maybe we'll do some bonus footage with those networks. But anyway, let me show you what we got. We got our meter set up. Can you read it? Of course you cannot read it. Why don't you ever tell me when you can't see stuff correctly? Get the angle right. I think you can see that meter. You're just going to have to do your best and squint or whatever. Our first 5 volts, we have 2 5 volts. We have one on our black connector, and we have one on our white connector. Everything's plugged in, key is on. Let's take our T-pin and find our orange wire in pin 17. And so here's our orange wire back pinned, and you will see we connect our meter to it. We got 1.16 volts. Can you see that? I'm going to have to set this up to where maybe I can see if you can see it's in shot. I can see 1.16 volts. This should not be 1.16 volts. This should be 5 volts. And what I will tell you too is be careful when you're plugging these in. You get some weird numbers. Let me see if I can zoom in on that. We're just using a normal T-pin, and from experience, occasionally, it's not super common, but occasionally, if you push this T-pin all the way through that connector, you can touch one of the other pins inside of there. And so to make sure that that's not what we're doing, I'm going to just start this T-pin in, and then I'm going to touch on my voltmeter the whole time. So we'll back it out to where it's not in yet. All right, so 0.1 volts, so we're not in there yet. I'm going to slowly slide this in until we get our first reading. No scope today so far. There it is. Just made contact 1.16 volts, and we're not in very far. We are in very shallow. We're about in that far, if you can see it. It's like a quarter inch. So we know we're making just pin contact. So that's an issue. Let's go back to our connector C2 with a violet and orange. Here's a violet and orange. We're going to do the same thing. We're just going to start it right there. So we got 0.1 volts. We're not in there yet, and slowly just slide it in until we get an actual reading. There it is, 1.16 volts. Boom. Now, here's what I'm going to do. Usually what I see is we're gonna draw. Let's say this is our PCM, right? We've got connector 1, connector 2, so PCM. Usually what I've seen somewhere for the 5 volt, even though we've got 2 different connectors coming in for 5 volt, somewhere in the computer they tie together. And so my very next test is going to be unplugging each one of these one at a time and seeing if the 5 volt is restored on the other. So let's see if that happens, because we also want to split the circuit. If I can eliminate, C1 or C2, then I'll have to check every single sensor on here that's got 5 volts going to. It'll make it a little bit easier for me. But we may not be able to do that if they're actually tied together on the circuit board. But if they're not tied together, then this test will be helpful. Anyway, let's say, so we got our, get this slid in just a little bit further, 1.16 volts on C2. I'm going to unplug C1 and see if this changes. There went up to 2.4, but we also would have potentially lost, we also lost power to our PCM. So we'll keep that in mind. Let's do the same test. We did have some change. Since we had some change, maybe we might be going after sensors tied to connector 1 there. Now let's do the same test in the reverse order. There's our 1.15. We'll unplug this one. Still 1.1. That tells me I'm leaning towards whatever our 5-volt reference circuit feeds on connector 1. I'm thinking likely is going to be our issue. Now let's go back to a wiring diagram and figure out what sensors get their 5-volt from C1, and then go from there. I believe that's our next step that I can think of. All right, on this car, looks like all the powertrain diagrams are all in one giant list. Like this thing just goes on and on and on and on. Not even halfway there yet. On and on. Printed off the ones that I think are relevant. Let me get this camera set up. I'll show you that. Okay, coming back here, we've got our 5-volt supply on pin A17. I just scrolled through that long list of stuff, and all I did was look for where it said powertrain control module. I just went across, and if it said A17 on it, I printed it off. So we've got an A17, and we got 3 pages that are all stuck together. We got an A17, and then we've got another stuck together pages. Come on, hands. We're on the internet. Everybody's watching us. A17, and then figure out where they go. Once I found out that it's going to go to a splice, I also did the same thing. Scroll through the whole page and look for anything with splice 115. They're actually just the same diagrams. But anyway, man, I'm just throwing my stuff everywhere. Jeez Louise. All right, map sensor is 1, and then it's like throttle position sensor is another, and then it looks like, cam and crank. That is the order we're going to go through this in. We will get our meter hooked up to here after we turn it back on, and hopefully y'all can see it. We will repin our 5-volt, or our should be 5-volt, and clip that onto there. All right, 1.15 volts. You can pretty well see that. And then we're going to go map sensor. I have no clue where the map sensor is on this thing. We're just going to have to find it. All you 4-liter guys can laugh at me. Like, it's right there. I assume it's going to be somewhere on the intake. Probably should have cleaned all this up before I started, but it is what it is. That looks like it might be a map sensor. It looks like a 3-wire sensor, and it's got an orange going to it. Let's unplug that dude. The whole thought on this is, we're going to have to get something to try and not break that. The whole thought on this is something's pulling down that 5-volt. Most likely, it's probably a sensor. So we just go through all the 5-volt sensors and try and figure out if one of those is shorting it by unplugging it. If it does not, well, I don't know what you just lost because my phone is dying. We got the meter set up on our 5-volt. We're going to go through the list of sensors on here because the theory is one of these sensors is most probably pulling this circuit down. We're going to start on our map sensor. It looks like this one. I assume it is. It's got an orange wire going to it, which is our 5-volt. So we're going to try and gingerly pop this off. So we have very minor change. Probably not our issue. Let's see. What's our next page? Throttle position sensor. That's probably on the back side there. Make sure you can still see all this. Yeah, you can. So throttle position sensor back here, it looks like. See if we can get this off without breaking it. Oh, the tab depresses, so that's always a good start. And a wiggle. And no change. All right. Doesn't look like it's either one of those two. Next one. Looks like crankshaft and camshaft position. I don't have a clue where either of those are. And again, I'm sure maybe you didn't hear me the first time because my phone cut off. But I'm sure all of you all of you 4-liter guys are just screaming at me. It's right there. It is what it is. I'm assuming the cam sensor probably gets. Well, my phone just overheated, so I don't know what you caught and what you didn't. 4 things that feed, looks like that it feeds for the 5-volt. We have throttle, map, cam, and crank. I just picked this vehicle up and looked under it. The crank sensor wiring goes up to the top here, but the crank sensor is new. And so we're still plugged into the 5-volt. I've not unplugged this one yet. Let's go ahead and unplug our crank sensor. Oh boy. Well, that did not fix it. That means one of a couple things. We go back to my drawn, my real crappy drawings here. Now, either we're on the wrong path, or this is the case where these 5 volts may tie in place. Now we're going to have to go to C2, and our 5 volt on C2 is B31. I'm going to go through all those diagrams again and figure out what circuits go to B31 on our PCM. Well, the only thing that I could find that B31 feeds is 5 volt to the vehicle speed sensor, which looks like it's on the T-case output. Let's go underneath the vehicle. Righto, we're underneath here. This looks like our speed sensor. Let's see if we can disconnect this without breaking it. Okay, that is unplugged. Let's cross our fingers and hope that our 5 volts come back. It is not. Well, crap. That sucks. Let me think about this. Okay, we really only have about like 3 more tests that we can do, and we're actually going to have to go to the whatever it's looking at, to the CCD bus and probably whatever the SCI transmit receive is. This is what we're thinking. According to the wiring info, there's only 5 things on this car that use a 5 volt reference. 4 of those things come from connector 1, cam, crank, map, throttle. The last thing comes from connector 2, that's the vehicle speed sensor. And something is pulling that voltage down from 5 volts to 1.1 whatever. And we usually assume it's something in the car that's pulling it down. Since we have unconnected or disconnected all the sensors, now we start to think we've got a PCM issue. That said, we could still have something in the 5 volt reference, like if we got wherever that wire runs throughout everywhere, it could be rubbed through somewhere. My screen just froze. Hopefully I'm still recording. I better stop and restart. So that 5 volt reference could be shorted through some other harness as well, like partially shorted to ground or whatever have you, since it doesn't seem like it's a sensor issue. That could be one of our issues. Or 2, the PCM could be bad and just is pulling down or not putting out that 5 volts like it's supposed to. And so we're going to do a little bit of our homework now. We have to find the brake or the park interlock, the shift interlock. I need to figure out what feeds it because it happened at the exact same time this issue did. And the brake switch, it looks like in some of the diagrams, the brake switch is fairly complex. It's got like 6 wires going to it or something, 4 to 6 wires, something like that, because it feeds cruise control as well as signal to PCM or whatever, as well as the brake lights. And we know the brake lights at least work, but there could be other circuits in there that do feed the engine computer. So I need to figure out how the shift interlock gets power and ground, and then we'll need to test that. Likewise, we're going to need to test the CCD bus and the SCI transmit receive, whatever that is. We're going to test those with the module plugged in, and then we're also going to do the CAN bus test with the PCM unplugged, because if the PCM ruined or died or whatever, and it's not outputting a 5 volt, it could also be taking down the communication bus, which is why we can't communicate with anything on the CCD bus. And there's a few things that are on it that we should be able to communicate with. Specifically, if we go to that diagram, I believe the transmission controller, if it has one, Yeah, so, oh man, there's a whole bunch of vehicle options in here, but depending on depending on the buildup, the CCD bus has instrument cluster, immobilizer, the compass, the overhead immobilizer, powertrain computer, transmission computer, and that's it. So we don't have, according to the pre-scan, we don't have communication with any of those modules, assuming all those modules are on this car. You know, the engine computer is. And so we need to figure out if the engine computer is pulling everything down. So we're gonna figure out what controls the shift interlock, see if it's the engine computer. We're gonna do a CAN test with the computer plugged in and unplugged. And then lastly, the only other test, and this is actually 2 vehicles in a row that I've done this test to. I don't like to, but we'll use this diagram as a specific example. Let me find. For example, this is connector B31 or pin B31 that feeds the vehicle speed sensor. We unplugged this and we still have an issue. It's possible this wire could be shorted somewhere in the car, and to confirm that it is not, we're going to have to cut this wire. And if we cut this wire here, and like right at the connector with enough room to repair it, and our issue is still present, we still have 1 point whatever volts here, and we do that for both connectors, then the PCM's bad. I will double check PCM powers and grounds with a heavier load test lot to be absolutely certain before I condemn it, but it's kind of looking like we got a bad PCM. Let me pull the service info wiring diagram for all the stuff we just talked about, and then I'll bring it back. Okay, this was a fair amount to track through. The only thing we have that tells us anything about the shifter interlock is this description and operation of the interlock. Prevents operator, we already know what it does, but basically, when the ignition switch is in the start or run position, circuit A22 feeds circuit F15 through fuse 25 and the junction block. So realistically, fuse 25 and the junction block is our key information. And so we went to junction blocks. Well, let me get the printed version of all this. It still ain't great to see, but it's what we got. Basically, fuse 25 was in the junction block as our starting point. So fuse 25 in the junction block, it feeds wiring diagram 81219, 81220. And so the next one is going to be our 81219. We've got fuse 25 feeds HVAC, and then tees off and feeds shift lock solenoid, also extended idle switch, whatever that is. Also breaks off, feeds analog brakes. This is interesting. And relay, ABS relay. That was 81219. This is 81220. 125, same thing, and then same thing. So pretty much the same diagram. Let's go back under there and check our 25 amp fuse and see what in the world's going on there. I misspoke in that last clip. I said 25 amp. Fuse number 25, 15 amp. And by the way, this is we go to the shifter interlock last diagram. So let's take us to 8W31-4, which takes us to the shift interlock here, which goes straight through the brake lamp switch. And so we're going to check this fuse, and then depending on the case of that, we'll go down here and check our stop lamp switch just to be safe. All right, trying my best to get you on in here. These fuses are labeled right on the side of them, and so we're looking for fuse 25. There's number 25, and it's a 15 ampere. You can see we got our test light lit on that side as well as that side. So we got power through there. I guess our next thing is, this should probably be easy to get to. Let's pull diagram 833.3. I don't know what this is going to have to do with our PCM. Let me pull this diagram and see if it overlays with our PCM somehow. Okay, you're going to have to follow me through this part of the diagram. We've got to put 2 different diagrams together to get to an inference on what may or may not be wrong, and we're still trying to condemn the PCM through this. Anyway, just follow me through this. So we're trying to put together as much information as we can before we go to the vehicle so we know what to expect. fuse 25 15 amp, has power going through it, and it feeds the shift lock solenoid. The shift lock solenoid is actuated by ground through terminals 1 and 2 on the stop lamp switch. Okay, this is incomplete, and so we go to a different diagram. Get the camera moved around. So 8W333 stop lamp switch. This is our complete. It says it's complete, but the diagram's not. Look, pins 1 and 2, pins 1 and 2. Here it says 2 goes to ground through a splice, which we know that it's supposed to go through the shift lock solenoid. Also, pin 1 follows through to the powertrain control module stop lamp switch sense. This tells me, so here's what it tells me and what I'm going to hypothesize before we go to the vehicle. When this switch is open, we should have we have no path to ground, and so all the way through the shift lock solenoid down to pin 1 should be 12 volts. When this switches to ground, it grounds this circuit and will actuate our shift lock solenoid. When it's actuated, we drop 12 volts across it, and so this would then be 0 volts. So stop lamp switch open should be 12, closed should be 0, and that would be, to the best of my understanding, how the PCM would sense the stop lamp stop switch position. Now, how is it that we can have two things happen at the same time? And this would be really cool if this has actually happened this way. But if the PCM has failed and is somehow outputting 12 volts on the switch sense, so if it puts 12 volts on pin 1, it'd be 12 volts on pin 1. That would short that to ground, yes, which would likely fry that. But also, if we have 12 here and 12 here, our shift lock solenoid would not actuate. We would not actuate this because we have the same voltage on both sides. I'm going to figure out how. Let's go into the look at the dash. Let's pin this out with voltage and see what we got on our stop lamp switch. I have not gone under the dash yet. We're going to check it from the engine computer and see if we can. The stop lamp switch sense pin, connector 3, pin C24, that should have 12 volts on it as long as this is in the open position. Let's go to C24. C24 is a yellow and red, it looks like. So C24, that's not what we have. That is a pink and something. When our colors don't match, at least I'm looking at the numbers here, and it says 24 right there on that side of that connector, and it says a white and pink. Let's go to our connector views for C3 and try and figure out what our difference is. All right, here's our connector C3 and C24. Oh, look at that. The diagram's wrong. Imagine that. C24 is a white and pink stop lamp switch sense, and here it says yellow and red. So that's wrong. Cool. All right. This is why we double check everything. That means 24 is a white and pink, and 23 is a light green. Is it a white green right next to it? It is. And on the other side looks like a green and orange. Green and orange. It is. Okay. So our pink is our one we're looking for. We're going to start with just voltage and see if we have 12 volts on this circuit. Hey guys, it says 0.06 right now, so we're going to slide this pin in. Ooh, we have no voltage there. Actually a negative voltage. Pulling it out. So we know we're making contact. We'll re-stick it in a different side. And make sure the key's still on. The key shouldn't matter at this point, but the key is on. Let's turn the key off and see if anything changes there. Essentially 0 volts. Well, do we have 0 volts? Because, all right, we're going to have 0 volts because of a couple things. Either I don't know. This may be stuck in the closed position. We got to go to the stop lamp switch next. Let me back this vehicle out so we can get to it. All right, well, we have more inconsistency in service info. Under here, up there, but you cannot see. Come on, where are we? There it is. There's our brake light switch, and it has 6 wires going to it. I got to double check colors, but it looks like these are our 6 wires, and so this is correct, but the pin numbers are wrong, because this says 1 and 2 go to the PCM or whatever and ground, and here it says 1 and 2 come from power to ground. Let me figure that out. I'm basically going to test all of these wires on the stop lamp switch, and I'll just tell you what I figure out. All right, we were a little wrong on our stop lamp switch. It appears this is the natural position, and when you hit the brakes, it actually opens this circuit because on our white and pink wire, and our white and pink wire, which is interesting because on left-hand drive is white and pink, and then it comes on down, it says white and pink, but then changes to yellow and red again. Anyway, it's white and pink. When we hit our brake lamp switch, this one, our pin 1, which is our switch sense, pin 1, switch sense, when we hit the brake pedal, it goes to 12 volts. And so this appears to actually be correct, which makes me curious about the shift lock solenoid wiring still. Still not seeing how this ties into the PCM. Let me think for a minute. We also have no voltage output on our speed control source, which goes to the brake switch and then down to the cruise control, it looks like. Let's unplug this. Let's just unplug this brake switch. Well, I will tell you, it's a little difficult to figure out exactly what's happening here. I unplugged it. We have no change on anything except for white and pink. Our white and pink now has 12 volts on it, which we would expect because it's coming from the fuse and it's an open circuit. And when I put a test light on it, it lights dim, as if it's powering, dropping voltage through our shift lock solenoid. I guess let's see if we can get this shift lock solenoid. We'll see where it's at and see if we can test on either side of it. That's where I'm at right now. Well, that is our shift lock solenoid. This is going to be about as far as we're going to go on this one until we just think it's not related to the engine computer stuff. Shift lock solenoid comes from, and you can't see anything, power, and then power's on the dark blue and white, and then ground goes to stop lamp switch on the white and pink. That's what it's supposed to be. Let's see here. We'll get our meter turned on. We'll just do voltage first. Which I don't know if you're going to be able to see everything. You're probably not going to be able to. Whatever. Our meter's right there. And we're going to test really, this should be an open circuit, so we should test either one of these, and it should have 12 volts on it. We'll test the pink and white, or white and pink. We have 13 volts. Whatever. 13 volts. I just slipped off of it. 13 volts. And then we'll test the blue and white. Should have same 13 volts. We do. Now, let's go ahead and plug back in our brake switch. And we just lost our meter ground. Let's see if we can find a new meter ground. It's not the way of a brake switch. Just retesting voltage. Good, we got a good meter ground. We're going to go back in and re-plug in our brake switch. Right there. That's plugged in. And now we will retest there. We should have 12 volts on pink and white. Oh, buddy. Oh, no. That's right. Because that's grounding it. But is it supposed to be? So we have ground on pink and white because it's supposed to be actuating the solenoid. But I don't hear it click. We have 12 volts. We do have 12 volts on the other side. All right, we are dropping voltage across this solenoid right now. Right now, in fact. But I didn't hear it click whenever we unplugging the brake switch again. Ooh, it's hot. Like it is warm. Something's going on here. I feel like this brake switch is backwards or something. Because why else? I'm gonna have to think about this. I'm not convinced this doesn't have something to do with our PCM, but I don't know how. Because some of these wires for our brake switch do go to the PCM, and we've still got a PCM issue because we still don't have 5 volts. Let's go and, for grins, let's leave this unplugged. Let's go retest our 5 volts. We might be pivoting to the PCM 5 volt thing again. All right, we're back at the 5 volts. That unplugged. I don't think we're going to see anything different. If and when this doesn't pan out, the only other thing we can do is start chasing, spark and fuel. Oh, I can't get this thing to bite in here. There we go. Now we're at 0.5 volts. Well, we definitely have a dramatic difference on that 5 volts. Make sure I'm on the right wire here. Last time it was 1.16 or something like that, wasn't it? A17 orange, A17 orange. Let's do the other side of the wires. Make sure we're not poking all the way through. Now we're at 0.5 volts. Man, what is happening? Okay. Let's move to connector 3. And 3, I think, was a violet, or connector 2, violet and red. Is that what it was? Oh, it's right in front of me. That was silly. And we just lost our ground. Man, I'm starting to struggle on this car. Hope y'all are enjoying the entertainment. Connector 2, B31, violet and orange. There's a violet and orange. And 0 volts. Connector 2, B31. Should be 5 volts. Oh, shoot. I will tell you too, off camera, I plugged all the sensors back in. Let me unplug all the sensors again. Dang it. So that was crank. This will be throttle, and then this will be map. Oh, map is still unplugged. Not that really changes it. So map is still unplugged. Let me unplug cam, or distributor, whatever you want to call it. Leave this one the same. 0.5 volts still. That's very strange. Let me plug in the brake switch again. So brake switch is plugged in, and 0.5 volts. Is the key on? Like, what did we do? What changed? Key is still on. We'll key off. We'll key on again. Still have no check engine light. Still 0.5 volts on the 5 volt reference circuit. That is a problem. I do not recall exactly where we left off. I ran to do something different. We've got the brake switch unplugged. We've got all our sensors plugged back in except the vehicle speed sensor. And our current question is the engine computer bad? And we've got powers and grounds in the engine computer. We don't know if we have, and we have no 5 volt reference, but we don't know that we have communication. And so everything's plugged in. We'll check our 5 volts. We've got the scope up here. There it is. So we've got very, very close to whatever we had last time. So we got 0.5 volts about, which is not what we're supposed to have there. And then I think we had about the same on this other one. Yep, 0.5 volts or whatever. But this changed, and we don't know why it changed, because we had 1 point whatever that y'all saw in the video. Now something changed. The brake switch, I believe, is still unplugged. Let me double check. Brake switch, it is plugged in. Let me unplug the brake switch, just to be, because we don't entirely know how the brake switch works, because the wiring kind of sucks. We'll just recheck these real quick. I assume we're gonna have the same, because nothing in the 5 volt goes to the brake switch. And so we need to have confidence that this thing is bad. we're going to check our CCD bus plus and minus, our SCI transmit, and our SCI receive. Now, right now, the VCMI is plugged in, and what we are going to do is go back here, and while we're checking for our CCD bus on the scope, we're also going to we're going to try and communicate with the engine computer and see if anything shows up on the scope. I guess we could have used the OBD thing, but that's all right. Well, I think we just put this thing into an infinite loop. So we're going to check it with the computer plugged in. Then we're going to do the same check where we try and get the tool to communicate with the PCM with the CCD connector, which is connector 3. Looks like our CCD bus goes to connector 3. We're going to unplug it and see if we get network restoration. And if we get network restoration, we know the PCM's taking it down. And I'm probably going to do the one final test. We're probably going to cut our 5-volt wires, but I want to do that last. And then we'll cut it in a way that we can fix it all pretty like. Make sure this thing's still recording. Looks like it is. All right. Connector 3 looks like C28 is a white and black for CCD bus negative. Oh, can you see it? It looks like it's trying to, let me stop this and blow it up. Zoom in. It looks like it's trying to talk and it cannot talk. Can you see it? You can. This top part here is 2.5 volts. So it goes from 0 when I make contact, 2.5, and we get an occasional trying to spike down. This looks very reminiscent that something is trying to talk and cannot talk. That is helpful. What is going on here? Still says initialize and whatever in the world that means. Let's go ahead and hit play, reset our time base. And yep, still same thing. Now this was CCD negative. Now let's go CCD positive. All right, this is also 2.5 volts. We don't have the dropouts like we did. Did it get, okay. Device unable to communicate with control unit. That's perfect. Let's do split screen. That one, come on. Whenever we try to communicate with our engine computer, we'll hit escape. It seems like that thing got grumpy. Let's hit and try to communicate again. And when we do, let's see if that starts to drop down. Boom, had a little bit of a drop. Very, very minor drops on this one. It looks like they're very, very, very minor. Let's go back to the other one and see if they're still more pronounced. Yes, they are more pronounced. Oops, we had a bad connection there. They are more pronounced on the low side than they are on the high side. Yep, that's the high side. Looks like it's trying. Yep, it's trying to communicate. Okay, now at this point, we will disconnect our engine computer. That is not pulling, not what I expected to see. Let's go to the other one. That is not what I expected to see. I really don't know what we're chasing on this car. I'm just going to unplug this engine computer all the way around. And we are going to do a fault scan on this. And it will go through. Obviously, it's not going to ID the computer, but we'll see if any of the other computers come back online. Here's the other thing. If we have this engine stopped running at the exact same time that we had our shift interlock issue show up, I'm concerned that even if it is a bad computer, is there something else in the car that pulled it down or shorted it or whatever? And that's what I'm having trouble figuring out. How do we tie in the shift interlock failure to the engine running failure at the same time in conjunction with our 5-volt failure and with our lack of communication, even with the PCM unplugged? Like, these signals are not, there's a very small possibility that we're zoomed out too far. We can zoom in. Yeah, no, let's set a trigger and just see. Oh, maybe that was communication. Maybe we are zoomed out too far and I just didn't know any better. Let me do a little bit of research here on the CCD bus. Maybe that was my fault. I may have just totally misread that. Let me figure out CCD bus voltages. I believe I may have misled the internet. My apologies. So CCD bus description operation doesn't tell us anything, but when we zoom in to where we saw that noise, those are actual messages that are getting sent. And every time it's trying to go through and find one of these, it sends a message out. All right, we changed this up a little bit for the CCD bus. Did some Google searching, and it looks like we have the right voltages. And I'm also going to make some messages a little bit cleaner, which I usually don't do this way very often, but it doesn't matter. It's a fine way to do it. I've got our negative going to, on the scope, our negative going to the bus minus and our positive going to bus plus. And that way it just gives us the actual deviation. So here's our actual like messages that the car would be seeing. We'll zoom out a bit, and there's quite a few messages running across. We'll go ahead and hit the engine computer again and try to connect to it and see how many more messages start showing up. It's like a fair amount of more messages. It's like a couple are higher than others. I don't know if that's going to be. Oh, what was that? Let's zoom out a little bit. Some of those spikes are kind of high. That I don't know if is normal. Ooh, like that one. What was that? Why did that go so high? Let's redo our scale. Let's do a 5 volt. I don't know what those really high spikes were. But the PCM is communication. The PCM has power. The PCM has ground. The PCM does not have 5 volts being put out. Why does the PCM not have 5 volts? It's got to be a bad PCM. We've got to cut our 5 volt wire. I don't know what else to do in this moment. Let me get this plugged back in. We'll get ready to cut the 5 volt wires. All right, we're getting everything plugged in. Rechecking our 5 volts. Key is on. I cycled it actually. So we've got our orange 5 volt wire, and it still is 0.5 volts. We'll go back to our purple 5 volt wire. Still 0.5 volts. Let's just double check this on the engine. I don't know where my light is. We're going to go into throttle sensor. Hang on, let me grab my light so I can see what wire's what. We're going to unplug it. We're going to be done with it. The front probe, we're not jamming in there. We're just touching. There it is. We're at 0.5 volts. We'll check the other one. Also, it's a little bit less. The return is a little high. Well, that's kind of, I don't know what that's supposed to be. There's our ground. I don't know why the signal is like 0.25 or something, but whatever. They're the same. Are they really the same? So 0.5 is the next one up. Let's touch these again. That's very strange. That's right at 0.5. That also is just under 0.5, like 0.49. That's a little weird. All right, let's do our map sensor. We'll just unplug it and touch our orange wire. Yeah, same one. All right, we've got to cut these. I don't want to, but we've done every other test that we can do. If you're not paying, or if you're having trouble following what we're cutting and why, we're cutting this 5 volt wire on each one of these connectors because we need to know whether the issue with the 5 volts is on the vehicle side or on the PCM side. And it seems like it's on the PCM side. That said, the only reason that we think it's on the PCM side is because we have gone through all of the wiring diagrams that show us how, what sensor it goes to. And so it does not appear to be a sensor issue, but it could still be a wiring issue. And that's what we have to figure out. And the only way to do that is to completely isolate it 100%. The only way that I know how to 100% isolate it is to trim the wire right here. That way we can test both ends of the wire, the PCM side as well as the engine side. And then we will put this in a place so we have plenty of space to go through and mend it, because we will also mend it when we're done. Try not to short anything, cut more than one wire. So let's see, right, boom. All right, that has been cut. The first one has, we'll just measure a difference. We got to cut both of them because we think they're both tied to the same side, which is fine. So they probably both have the same voltage on it. I'll test the PCM side first. Boom, PCM still has 0.5. And the vehicle side, has 0. All right, now we got to cut the other one. So there's no future issues with it. All right, and cut. Second 5 volt has been cut. We will measure PCM side. Boom, still 0.5 volts, PCM. And then on this side, we have 0 volts. That's it. We need a PCM. This thing has communication. This thing has power. This thing has ground. But I don't understand what this has to do with the brake switch and the shift interlock. That to me is still very confusing. But we have no 5 volt output on the PCM. That's what these two nubbins here are. So we know we still have no 5 volt out, and there can't be anything on the vehicle side that's pulling down our 5 volts because we just literally cut it, and we're still at 0.5 volts. This thing needs a PCM. I still don't know. I'm just repeating myself at this point. I still don't know how this plays into the shift interlock. I'm going to do my best to figure that out, but we got a PCM 5 volt issue for sure. This is my potentially excited face. We're going to try something. This is a 5 volt generator. And we are going to see if we can power up 5 volts. Yeah, this is my 5 volt generator. Make sure I grab the right electronic thingy. And we're going to see if we can't power up 5 volts to the rest of the car and get it to start. My stupid battery's dying again. I don't know what you just heard. We have a 5 volt regulator installed right now. That dude right there, 5 volt regulator. And we're going to manually jump 5 volts into this car while watching the voltage just in case something's shorted, and see if that brings any of our issues around. I should have trimmed this a little. We'll pull the whole harness up here a little bit. It's tight around this air box. I may have to pull this air box out to make our proper mend. That's all right. All right. I'm running low on leads as far as reach goes, so that's it. All right, we're pierced in. We got 5 volts there. I'm curious. Let's move everything so it does start. We can, hopefully nothing falls. The question is now that we got 5 volts injected into the system, we still got to plug our sensors in. It's not going to run very well without that. There's no doubt there. And then we're going to double check to make sure we got 5 volts going to the actual sensor. I'm going to temporarily pull my scope off of this pierced wire. And then we will back probe our map sensor. Keeney from the future here, editing what you just watched. Phone kept dying and overheating and all the other stuff. When we use a 5 volt generator, the 5 volt generator will ground to the same circuits as the car, and then obviously we have a 5 volt that we can put wherever we want. And so we injected it into the engine harness side, and because it's still grounded through the car, that should give all the sensors. We did it through connector 1, pin 17, I believe, and looking at the diagram, that'll give the cam, crank, throttle, and map sensors the 5 volt voltage they need to function. And the thought is if they have the 5 volts that they need to function, then the sensor should actually work correctly, and the return signals from those sensors should be correct going to the engine computer, assuming the engine computer can interpret those signals correctly. That was the thought with the 5 volt. The next clip you will see it didn't actually work, so still a computer issue at this point. But I hope that was a helpful clarification for this step that kind of got cut out. My phone overheated again. I don't know what you're getting as far as when the video cuts out. We took a a 5-volt generator and plugged it into the 5-volt circuit, cranked the engine, still does not start. Whatever. If the engine's not going to fire stuff, it's not going to fire stuff. But I'm still hung up on this shift lock solenoid. Something's not right with this. Even when I was doing testing with the test light, I never heard that solenoid click. Let's go back under the dash real quick. Brief reminder on shift solenoid or shift lock function. Has power coming in on the dark blue and white, and then coming out on white and pink, and then it goes through the stop lamp switch to ground. When I take my test light and touch it to dark blue and white, it lights brightly. When I take it to white and pink, it lights dimly because it's dropping voltage across here. But this doesn't click. Even if I take it straight to ground, it's not going to click. I don't know what caused PCM failure, and I don't know how this shift lock solenoid is tied to the PCM. I cannot prove it out. I'm just whining and complaining. I cannot prove it out in the wiring diagram. I'm trying to come up with a logistical process of, if this could have happened, how does it explain PCM failure? And I don't have it yet. I don't know how this is tied into the PCM. Certainly wires from this go to the brake switch, go to the PCM, but I cannot fathom yet logistically what type of failure would have caused an overcurrent in a PCM. And I need to make sure that none of it did. I might have to step away from this one for an hour or a day or a night or something to think about it, because I don't want to plug in a new PCM and have the same issue, or I shouldn't say have the same issue, because we know the PCM's fried right now, but we don't want to fry the new PCM. That's what I'm concerned about, frying the new PCM. I'm just probably going to step away from this for the day or tonight. Maybe come back to it and read these diagrams, and then catch you up tomorrow or something whenever I've had a chance to sleep on it. But I don't know how this ties in. I'm concerned that it could lead to another PCM failure if we put a new PCM in first. Well, I have since stopped my timer on this thing while I decided to go back over everything that I've done since the beginning, and the only thing I can find that doesn't line up or doesn't make total sense is the wire color for connector C11. So coming out of the I misspoke, C24. The signal, the stop lamp switch. So this is our stop lamp switch. That wire here for left-hand drive that's blurry is a white and pink, and then it goes on down and says it turns into a yellow and red at the engine computer. It does not turn into yellow and red. That's the only thing I can find. I even went through all the stop lamp switch wiring. The stop lamp switch wiring appears to be correct. The two wires where we did not know where they go just gets power from a fuse and then sends it to the chimsel and the two side brake lights, which all work. So we know that works according to the shift lock solenoid diagram. We get power coming into the top of it, and then this is what's interesting, but this appears to be correct, and it matches the diagram. It's how it works in the car. It would appear that the shift lock solenoid is always engaged. So with the brake pedal released, no brake pedal action, the shift lock solenoid is grounded according to this diagram and in the real car. I've substituted a test light with a shift lock solenoid and the brake switch plugged in, and it lights. And then you push on the brake pedal, it opens this switch. And when it opens the switch, two things happen. One, the shift lock solenoid loses its ground and therefore loses its functionality. Also, when it opens and loses its ground, the switch opens, we get a 12-volt signal on the PCM side or on the bottom side of the shift lock solenoid. So when the switch opens, we lose our voltage drop across here, and then we have 12 volts here, and 12 volts goes down to the engine computer. That does happen. I guess I could show you that real quick. We tested it not directly, But when I was doing my voltage checks at the different PCM pins, we did see 0 volts on the brake sense wire or the stop lamp switch sense wire or whatever. And that's because the brake switch is pulling it to ground on the ground side. And that matches, like it matches. And so I did also measure the resistance of the shift solenoid, and it's at 42 ohms. For a solenoid, to me, that seems a little high. I will tell you, that seems a little high. I checked all of my part supplier websites, and it's past the dealer hours right now, but I've checked all my part supplier websites, and they don't even offer a shift interlock solenoid, a transmission cable. Like, I've searched all the things and I cannot find one for it. We're going to have to call a dealer tomorrow and get a part number on it, see if we can search it via part number on the internet, 'cause I'm sure the dealer won't be able to get one. But the long and the short of it is, I think the engine stalled. This is subject to a good night's sleep tonight, right? We're walking away from this one for today, to make sure we got a clear mind on it. It seems that the PCM failed. It lost the 5 volt, and that caused our engine to stall. It seems like happenstance, the shift lock solenoid failed at the same time. I don't have any better explanation. I do not have any. I realized I may have been misspeaking. This says transmission controller. This says engine computer. Either way, this signal operates correctly. I was pointing down here at trans, but I kept saying engine. Engine computer's right next to it. I just noticed that, and then I'm panicked for a minute. Tell you what, let's go back. We can do that check. We'll just pull out the PCM pin there. We'll plug in the stop lamp switch, and then we'll see the brake transition, and it'll transition correctly through the shift lock solenoid because we do have continuity. So we got 42 ohms. Doesn't matter what the resistance is. It does not matter. When the brake lamp switch is closed, the PCM and TCM will test at the PCM. PCM will see 0 volts because it's being pulled to ground. And when you push on the brake pedal, it will open that circuit. It doesn't care about the 42 ohms, and we'll see 12 volts at the PCM. And we can do that test. We'll go do that here real quick. But I've been through all of my notes, and it just seems like, to me, subjectively, 42 ohms seems too high. I think the shift solenoid just failed at the same time. I don't have another explanation. PCM lost 5 volts. That's why everything fried. And I don't remember if I mentioned or not, the crank sensor on this thing is shiny, so it has been replaced. I don't know if that's going to cause a startability issue later on or not. Hopefully not. But it's also odd that we've had multiple failure modes, if you would, on this PCM. We lost our 5 volts, and we have no communication to it. I don't know why we don't have communication. We're going to do 2 tests I just came up with. We will verify the brake switch operation, like I said. We're going to take a generic scan tool, just in case the Chrysler collision detection setup is not working on this car. We're going to take a generic scan tool and plug it in and see if we have codes. Let's go do that. Let's go see if our COM issue is a tool issue and not a PCM issue. All right, to the best of my ability, we're plugged into C24, and our brake is up. I think I'm back probed in correctly. Hopefully I am. Here's another pro tip for you. If you want to know if you're making connection on a back probe, zoom in really, really, really far. Watch this. There you go. See all that noise? The signal will change somehow when you actually make good connection. It will make a notable change. Also, if you wiggle this thing around, it's going to make noise. So you got to go smooth for a second. And then once it's smooth, you're not wiggling and shaking the cable, just plug it in. Boom. See it jump? We know we've got connection. Pulled out. Boom. Pulled in. Now we know 100% when it's high. There it is. Make sure it's in there good. See, we're losing it. It's a good way to know if you got connection or not. There we go. Now we know we have good connection here, so now we know everything's going to work. Just a little pro tip for you, how I always check. Do I have a good back probe? I just zoom in really, really far. So we're at a 50 millivolt scale there, and then just look for some sort of change. We'll go back to 10 volt now. It's on ground. Let me get my brake pedal depressor in. And we're walking around here, and we will depress the brakes. What do we have? Should be 12 volts. Oh, it's off scale. And it is there. Oh, it went really high. Oh, that's cool. We have a spike. Yeah, you can see it. We have a spike here all the way up to about almost 18 volts. Yeah, about 18 volts. That's going to be an inductive spike, probably from that shift solenoid reacting. But anyway, this voltage right here, 13 volts. So we know that's working. Yep. Last check. So we know the brake switch circuit is working like it's supposed to. Our last check is going to be to take that dude and plug her on in. We'll plug this dude in. Whoops, he just dropped on the ground. It's good for it. Alright, got this thing plugged in. It's auto detecting. Oh yeah, our screen's glitchy. I don't know if this phone's overheating again or not. Let's see if this thing has any type of communication. We could do this with the Autel too. Probably coulda, shoulda, but this is, I think, more of a foolproof. I guess that's the only protocol this thing does. Are you kidding me? Throttle valve return spring performance problem. Transmission range sensor Prindle input. And throttle. Definitely can be because we got our 5 volts cut. Dang. Man, how do we lose? Well, that's mildly frustrating. It doesn't change anything on our diagnostics. If you're following along, that's just aggravating. That means the Autel does not want to communicate with this whole thing. That's frustrating. Anyway, that means the PCM is communicating. And so if the PCM has communication, power, and ground, and no 5 volt output, it's a PCM failure. And I think the shift lock solenoid, because it has high resistance, I think it became internally high as far as resistance goes. I think that resistance just maybe got hot because according to the diagram, anytime you're off the brakes, that solenoid is engaged. Yeah, anytime. And furthermore, check this out. The fuse that feeds our shift lock solenoid is that's the test. There you go. The fuse that feeds the shift lock solenoid power is key fed. And so, if you have ground all the time, you have to cut power at key off or you're going to drain the battery because the solenoid's going to be locked up or energized the entire time. That makes sense. And so that means in this car, if the shift solenoid is working with the key off, you should be able to pull this thing out of park. Is that right? According to wire diagram, it is. With the key off, you can pull this thing out of park, but when you key on, it will no longer come out of park unless you hit the brake. I guess that's something we're going to have to test if we can find a new shift interlock cable for it. Otherwise, we will just probably disable that. I'm calling it PCM. I'm going to sleep all night on it, but I'm calling it PCM. I don't think that the shift lock solenoid had anything to do with it. As is good fashion on this channel, I always have just one more test. I don't know how many times I'll ever say that. I want to make sure our 5 volt signal isn't shorted to ground. And so to do that, I have unplugged all of the sensors again, and we should have no continuity. I guess I I was dumb. I should have left this plugged up. We're going to connect this end of the meter to battery negative. All right, it is connected to battery negative. And because all the sensors are unplugged, there should just be an open 5-volt, and it's still cut here at the PCM. This should just be open. And so we'll turn the beepies on. Can you see the resistance value? You can. So, well, there. Oh, well, still. Make sure we got good contact. Boom. We'll touch ground somewhere where we can have a good ground. Make sure. There we go. So it's working. I don't know if you can hear the beepies, but you can see the change. We're just touching the intake manifold. And so connector 2 has no short to ground. Connector 1, nothing. So we know our 5-volt wasn't shorted at any point in time, or shouldn't have been. At least it's not shorted now anywhere on there. We just have no 5-volt output from that engine computer. She needs one of those. It is the next day. We have slept well on the issues with this vehicle, and I did not come across anything else that this could be. Just going back to, we got a bad computer, and somehow our shift lock interlock solenoid is goofed up. I filed a trouble ticket, another trouble ticket with Autel. I filed a lot of them. I think they'd know me by now. On the CCD no response, because we did enhanced scan tool, no CCD connector, enhanced scan tool, CCD connector. We did generic OBD, no CCD connector, or their EOBD is what Autel calls it. EOBD with CCD connector. None of it works. They got a bunch of scans and stuff. Hopefully that will be fixed at some point. That said, I've got the thermal camera on another phone, and we're just going to check out the shift lock solenoid. The whole time, Autel is connected to their own scanner, trying to figure out what in the world's. Just can't win. Now apparently my phone memory's full, so we got to film this quickly after it's deleted some stuff. Key was on while Autel was connected to their scanner, trying to figure out what was wrong with it. And if you recall, key on, no brake depression, that shift interlock solenoid is going to be activated, and it is this whole time. It's getting hot. Let's see. There she is. 119, 122. Oh, there's the bright spot. Oh, 150. 160 almost. So 160 degrees. I don't think that thing's supposed to be that hot. I think that thing is just bunk. We're going to figure out a way to disconnect it so we can't really find another one. But I have to review all this with the customer. We need a PCM, and then assuming we get that and find a PCM for this old girl, we'll bring it back whenever that's done or ready. Old module, new module, and we got her plugged into the scan tool. Autel has fixed their CCD issue. We have communication to the engine computer, and they stored, I've not cleared codes yet, stored no CCD message, and the TCM is online. So we got 3 computers on this dude. Key is on and firing. Boom, it runs. Though the check engine light is on, I don't necessarily know why. I don't know why the check engine light's on. We just scanned it for faults. This is the only one that shows up. Though the vehicle speed sensor is still unplugged. I've not pulled it in the garage yet to get that plugged back in. So let me pull that back, pulled in, plug that speed sensor back in, see if that has anything to do with the check engine lights. And we also may have to go into generic OBD mode to see if it pulls a code. Because right now, engine computer, you can see it, engine computer is online, and it says no fault. So I do not know why that light is on. There might be a module issue with the remanufactured module, might be the speed sensor, but we'll figure that out and then close this video out. Okay, in enhanced mode, there are no codes present. In EOBD mode, there are no codes present. In the enhanced mode, live data, it says check engine light on, but on here, if you do, it's not plugged in the moment. Let me show you this on a screenshot. Okay, this is a screenshot because I've been plugging multiple tools in, but you can see the mill slips. The mill status is off. So the PCM, according to Autel, is not turning the engine computer on. Though I will say I used EOBD mode with the CCD connector. Don't know if that's going to change anything. I'll try it without that one next, because when we go to the generic scan tool from Wally World, we've got a few codes. We have a stored throttle. We have no engine bus messages stored, and also a transmission range sensor circuit. None of those codes showed up anywhere in any of this stuff. See, it says codes found is 0. So I don't know if this is because we're using EOBD with the CCD connector, but perhaps this pending code, I don't know if this is going to cause our check engine light or not, but check engine light, well, it's off in the very moment. But when it's running, so if I fire it back up, it'll probably come back on. So we'll crank it. Oh, well, look at that. Now it's off. I think it came on even shortly after it was running before, though. I'll leave it off. But the only next test I know to do is unplug the CCD connector, redo EOBD, and see if anything changes. Okay, we have the same result. There is no CCD connector installed. Still says mill off and no codes. Let's start it and let it run for a minute, see the check engine light comes back. I will speed this part up and see if it comes back on. Well, I have no idea what happened. Went for a test drive, no check engine lights, erased the codes with the Walmart scanner. The codes have not come back. The engine, battery's dying. Test drive, no check engine light, Walmart scanner, cleared codes, no codes present right now. Engine's running, no check engine light. I don't know what happened there. Here's what we got. Engine's running, no check engine light, no codes present on our horrible air codes, no powertrain codes present with a generic scanner. I have no idea what's going on. Apparently, we still got to call Autel because this pulled stuff that the Autel didn't. So Autel still got a bug they got to work out. But I reckon that's it for this one. She is fixed as far as I know. We'll tell the client that, we kind of had an intermittent check engine light at the end. Don't know what that was about. And that's it. We had a 5-volt issue, new PCM fixture. Hope this was helpful for someone out there, and I will catch y'all up in the next video.